Hi everyone, we're going to run through the revision final exam for EPMATH127. Okay, on to A1, express the ratio 196 to 16 in simplest form. Well, simplest form means we don't want any units in it, there aren't any. We don't want any fractions or decimals, there aren't any. And we want the smallest numbers possible to represent the ratio. Well, I reckon there's some common factors between 196 and 16. We can at least halve them because they're both even. But let's not do it the hard way, let's do it the easy way. Let's treat that ratio as the fraction 196 over 16. I'll put that in the calc, 196 divided by 16, and it'll tell me that's equivalent to 49 on 4. Hence, this is equivalent to 49 to 4, the ratio. So really what it did for us, it said, look, it had 4 as a common factor. It said there were 49 4s here, and there were 4 4s here, and that's as far as we can go. That made life easier. Now the next one, we want simplest form again. I said we didn't want this different units, or we didn't want any units in the ratio at all in simplest form, so we've got to make them the same, and then I can delete them. I like to change it to the smaller units. I'm going to leave the 15 minutes alone and change the 1.5 hours. 2 ways I can do it. One is to just do it manually, think, well, 1 hour is 60 minutes, half an hour is 30 minutes, so it's a total of 90 minutes. Or I could have gone to the calc and said, well, what's 1.5 times 60 minutes? And it would have told me 90 minutes. So now that I've got the same units on each side, it's the ratio, the universal ratio, 90 to 15, no matter what time period we use, as long as we use the same one left and right. And let's make the calculator do it again. 90 divided by 15, so I'm treating it as 90 over 15. Now it gave me the number 6. Now that doesn't mean my answer is 6, it means this 90 on 15 simplified to 6 on 1. So what should my ratio be? 6 to 1. So we must have said there's 1 15 there, and there's 6 15s there, so it's 6 to 1. B. A profit of 5,500 is to be split between Amy and Billy in the ratio 4 to 7. So here's Amy, and here's Billy. Amy's getting 4 bits, Billy's getting 7 bits. Well, how big's a bit? If we've got 5,500, and we've got to split into 4 plus 7, 11 bits, how big is a bit? 5,500 divided by 11, that is $500 per bit. So Amy's getting 4 bits of $500 each, that's 2,000. Billy's getting 7 bits of $500 each, which is 3,500. Now I wasn't asked that, but I do like to do the whole thing and just check, do my two parts still add up to the total of 5,500? They do. What did Billy get? 3,500. Was that the question? How much a profit will Billy get? Yep. Height of a building is shown as 6.8 centimetres on an architect's plans. If the actual building is 34 metres tall, what's the scale of the diagram as a ratio in simplest form? Well, scale things, we have a set left-right. It was in the form scale to actual, so I did my SCA scale, S:actual scale. And it's, well, what's scaled and what's actual? The architect's plan is 6.8 centimetres. That's the scale. That's not the real thing. The actual thing, the real thing is 34 metres. So there's my ratio, 6.8 centimetres to 34 metres. There's nothing wrong with the ratio, but we want simplest form. So let's get rid of units. I'm going to keep the small units again. 6.8 centimetres can stay there. 34 metres, well, every metre is 100 centimetres, so it's 3,400 centimetres. Remember, I've got that conversion thing in the notes. It's a little reminder for the resource sheet, how to convert between millimetres, centimetres, metres and kilometres, so that would be good to have. I've got the same units now, I don't need it. Now I can call it 68 to 34000, timesing both sides by 10. But again, we've got the calc. I'm going to treat that as 6.8 over 3,400 and see what the calc tells me is the simplest form of that. 6.8 over 3,400, it tells me it's the same as 1 over 500. There's my ratio, so this must equal 1 to 500. And there it is. And does that make sense that the big thing's on the right? Well, it should, yeah. Actual life is 500 times bigger than the left. So the scale thing times 500 gives actual. That sounds right. See. If a distance is measured as 82 millimetres on a map, so we've got a map again. How many metres is that in real life? Okay, we've got a scale. Again, it's SA. And it's given to be 1 to 4,000. So we're in the same direction. The scaled item is small. The actual item is 4,000 times bigger. Now the distance on the map is 82 millimetres. Well, that's the scale. A map is a scale drawing. These are 50-50, but it's pretty clear which way to go. One, by logic, that we know the real thing is bigger because I can see how the scalar set it. But if I was 50-50, real things can be small. It says scaled or left times 4,000 gives right. Okay, well, left times 4,000 gives right. My answer is going to be, well, I'll just go to the calc, 82 times 4,000, and it gives me 328,000. But remember, that's millimetres. And that little conversion thing I was talking about from the notes says, well, 1,000 millimetres is a metre, so it's 328 metres. I'll tidy that up a bit. Therefore, how many metres does this represent? Therefore, 328 metres. That's all good. Find the length of the hypotenuse of a right-angled triangle given the other two sides of that and that. Well, it's a right-angled triangle. Find the length of the hypotenuse. The main thing in these is to make sure you're picking on the right side, that you know where the hypotenuse is. The location of the other two doesn't really matter. But, terrible triangle. Doesn't matter. The hypotenuse is always opposite the right angle. I've got myself a 4.6 and a 7.3 in centimetres. Okay, and I know my formula, the Pythagoras formula. This isn't trig. I mean, I could use trig here, but it'd be a long way to go about it. I could use those two sides and tan to find theta, and then I could use maybe cos and this. Why go that way? If you've got three sides involved, it's Pythagoras' rule, and it's a right triangle, which all of ours will be. So the hypotenuse squared is equal to 1 of the shorter side squared plus the other shorter side squared. Okay, to get rid of the squared, I'll take the square root of all of this. I'll just deal with that in the calc. I've got a 4.6 squared plus a 7.3 squared, and then square root that answer, and it gives me to 1 decimal place. Oh, I didn't mean to do that. Undo it. Can I? It's not what I. Oh, that's pretty cool. It's a new laptop. Okay, you can pinch and zoom and stuff. 8.6 centimetres. It's multiple choice, David. There it is. 8.6 centimetres. Find the length of side x in the following. Not Pythagoras. We're back to trig. All trig questions involve two sides and an angle. One of them's unknown, but every trig identity, sine, cos, or tan, is saying sine, cos, or tan of some angle equals some side on some side. So sure, one is unknown, but it's always two sides and an angle. And that's what we've got. Now, what sides have we got? Compared to this angle, I've got the opposite side. I've got the hypotenuse, which is opposite the right angle. I don't have the adjacent. So it's a sine situation, SOHCAHTOA. Sine of my angle 62 degrees is equal to, opposite, which is 21, over adjacent, over hypotenuse, which is x. Okay, so this is it's not terrible, but the harder of the trig ones, where the unknown's on the bottom. Now I can do this next bit in 2 steps or 1 step. I just want to clean up that 6. I can bring the x over here, times both sides by x, and then take the sine 62 under there. Do it in 2 steps if you want. But it's going to work out that the x ends up here, and the sine 62 is down there. Now, make sure you're in degrees mode in the calc, okay? If you make sure you've got the letter D up the top of the screen. If you've got an R or a G, we're going to have a bad time. So 21 divided by sine 62, that deg just tells the calc that is 62 degrees. We don't have to put this degree symbol, but it just knows that whatever we take the sine, cos, or tan of, we're putting in degrees. And 21 divided by sine 62 gives me, to 1 dp, at 23.8 metres. There it is, B. Okay, don't. Find alpha in the following. Okay, still trig. What have we got compared to our unknown angle? I've got the hypotenuse, and I've got the adjacent. I don't have the opposite. So I've got myself a cos question. Cos, SOHCAHTOA, C-A-H, cos of alpha is equal to the adjacent of 4 on the hypotenuse of 7. What's the opposite of cos? It's cos inverse. And what's cos inverse 4/7? Well, cos inverse 4/7 is 55 we'll go to degrees, minutes, seconds. We want the nearest minute. It's 55 degrees, 9 minutes and 0.34 seconds. It's not a round up. it's not 30 or more seconds, so it's just 55 degrees, 9 minutes. A. Find the smallest angle in the right triangle of that. Okay, 3, 4, 5. That's one of our nice Pythagorean triads that are just, we don't need to know that, but that's just, it works out nice. 3 squared is 9, 4 squared is 16, they had to give 25, which is square root is 5. It's just pretty. Which is the smallest angle? Well, my picture is pretty good, and you can see that I reckon that's the smallest angle, but the smallest angle is always going to be opposite the smallest side in a right angle triangle there. So hopefully it makes common sense that, yeah, it's a smaller opening because of the smaller side. But you can always check it. We'll check it at the end, make sure I'm right. Now, here could be a potential point of confusion saying, oh, trick things, didn't he say it was 1 angle and 2 sides? Here we've got 1 angle and 3 sides. True, we've got more info than we need. Who cares? Let's ignore the 5 if you want. It's still true, and I'll just use tan. I can say tan of alpha is equal to 3/4. I could also have said that sine alpha is 3/5, or cos alpha is 4/5. Doesn't matter which way I go, I'm going to get the same answer. Alpha equals tan inverse is 3/4. Tan inverse 0.75 is 30, what do we want it rounded to? 36.8, so that's a 37 degrees. And is that the smallest angle? You bet it is. I mean, the angle sum of a triangle is 180, minus this 90 degree angle is 90, minus 37 will be 53. So that one's 37 degrees, that one's 53 degrees. Yeah, you wanted the smallest angle. All right, water. Find the angle of elevation from point A to the top of the tree. Here's me A. An angle of elevation is like, instead of looking straight ahead, I move my head up by an angle to see an angle of elevation. I move my head down to see an angle of depression. Point is, we always move off the horizontal. So here's my angle of elevation. Let's call it theta. Now let's find it. We've got tan again. We've got an opposite and adjacent, TOA. Tan of my angle, which I've called theta, is a 42, opposite, on an adjacent of 57. Hence my theta will be tan inverse of 42 on 57, which is tan inverse 42 on 57, 36 point blah, 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 B, 36 degrees. A3, where's the point -5, -4? Well, that's an X, that's a Y. It might not be marked, but we should know that this is the negative direction on the x-axis, and then this is the negative direction on the y-axis. We're down here in the C quadrant. Which of the following could be the equation for this graph? We're not expected to know anything too technical about these. We can always refer to table of values where we just test some points. Like I might say root x, well, what's root naught? Naught. What's root 1? 1. It already can't be that. What's root 2? 1.4. It already can't be that one. I also know that the square root of any negatives don't exist, so it's not you. Y equals 2 on x. Well, when x is 0, what's 2 on 0? Oh, the calculator's going to tell that's an error, that's undefined. There's no value, that's already wrong, because that thing is going to go like that. 2x cubed, well, I reckon it's going to be that one, because the x squared, I know, when you get negatives in square and they become positives, y equals 4x squared is going to be a happy face parabola. It's not you. It's definitely cubic. And let's check it. 2 times 1 cubed is 2 by 1, which is 2. 2 by minus 1 cubed is 2 by minus 1, which is minus 2. When you cube a negative, it stays negative. That's the one we're after. Given that y equals k on x squared, well, these next three questions are fairly similar. I just need to find k here. So let's sub in the values we're given. It says y equals k on x squared. Well, the y is a 4, the x is a 3, so it becomes 4 equals k on 3 squared, which is 4 equals k on 9. To get rid of this 9, we divide times both sides. It's already dividing. So 4 times 9, that's 36, equaling a k. C. The next one's caused trouble. In the mid-sem, it caused trouble, this sort of thing. I think in the mid-sem, we all just didn't read the word cube, just went, ooh, wish that wasn't there. I'm going to ignore it. Same thing happens to the word square. Let's go through it. The hours needed, H, to clean a house is proportional to, if we say is proportional to, you may as well just think equals k. Is proportional to means equals some number times, and that number is k. So proportional to is like equals k to the square of the months m. There's the months. I don't know why it's hard to read that square. Also, make sure you separate square root. That square, different from square root. But it happens. But that's all that sentence says. Hours is proportional to the square of the months. Okay, we've got a formula. Now they're chucking us some numbers to put in to find k. It took 8 hours. In other words, h was the hours. It's saying when h equals 8, hadn't been cleaned for 2 months, m equals 2. When h equals 8, m equals 2. All right, replace the h with an 8. The k is still unknown. The m is at 2 when it's squared. 8 equals k by 2 squared. 8 equals k by 4. Divide both sides by that 4, and I get 2 equals k. Hence that k up here I can rub out and make it a 2. h equals 2m squared. Perfectly b. Similar again. Variable a is inversely proportional. It's still proportional to is still an equals k, but the word inversely puts the other variable in the denominator. Variable b. It doesn't say b squared or square root. It's just b. There's nothing fancy, but the word inversely puts the other variable on the bottom. So it's not a equals 2b. It's not, no, there's no variables on the bottom there. It's either b or d. But let's do what it says. If variable a equals 6, so replace the a with a 6 and b with a 12. Well, 6 equals k on 12. To get the k by itself is being divided by 12. Let's times both sides by 12. 6, 12, 72 equals k. So now I go back to my k and say, you are a 72. It was a. Yep. A4, water. Write the equation of the following linear function in the form y equals a plus bx. Well, as long as we know a is the y-intercept, just the number 6, and b is the gradient, I like to automatically put the minus there. I can see that's a negative gradient, because if I walk along it left to right, I go downhill. Or just think of the letter n. It's got a negative gradient in it. But technically, gradient is defined as the vertical rise over the horizontal run. Picture this triangle. In moving from, say, point A to point B, actually don't use A and B because we've got a B in it. From point, don't use 1, whatever, point P to point Q. Do I rise? No, I fall by 6. So my rise is a minus 6. My run is, I went from 0 to 3. There's my gradient. I already knew it was a minus, and the 6 on 3 is a 2. The gradient's a minus 2. Does that look right? Yes, it's negative, and 6 on 3 is 2. Perfect. Y equals 6 minus 2x after I've subbed in A and B. Find the gradient of the line joining those points. Well, let's just go for a formula. We'll get our formula that says y2 minus y1 on x2 minus x1. And we were told, we know that that's an x and that's a y, that's an x and that's a y. Sets of coordinates are always xy. Doesn't matter which one cops the 1s and which one cops the 2s, but I'll just do it in that order, I don't care. I'm going to get the same answer. So it's minus 5 minus 4 over 6 minus 3. Minus 5 minus 4 is minus 9, 6 minus 3 is 3, minus 9 on 3. That's a gradient of minus 3. Move. There we go. Graph that on the flowing number plane. Okay, well, I can see the y-intercept staring at me. It's not always on the left. This question could have said y equals minus 2x minus 1. The y-intercept would still be the minus 1. The y-intercept, or the a value, sits by itself. The gradient here, that's a good parenthesis thing. The gradient is minus 2. Remember, if someone asks me what's the gradient of that, I don't quote the x. I don't say the gradient's minus 2x. No, the gradient is whatever x is being times by. The gradient here is minus 2. But firstly, the y-intercept's minus 1, so it's cutting through here. The gradient is a negative 2. If my gradient's a whole number, I always put it over 1 to think, what does that mean? If my gradient is that, it means go down 2 for every 1 you go across. It's going to look like that. Go down 2 for every 1 you go across. Yep, down 2, 1 across. Let's backtrack that a bit. 1, 2, 1, 2, 1, 2, 1, 2, and so on. And, okay, I don't have a ruler. It's not great, but it's, hey, look, if I do this, we can't see it anymore. Draw a neat sketch of that. I had to write neat, didn't you? Of the line y equals 3 minus a half x. Now, it says sketch, not graph. I'm not going to mark up the axes with all numbers and that. All a sketch is draw the line, label the axes, well, that's already done, and mark x and y intercepts. If it cuts the axes, just find the number where it cuts. So the easiest way to do that is, I know when x equals 0, I find the y-intercept, and when y equals 0, I find the x-intercept. But the y-intercept's easy anyway. It's staring at me. The y-intercept is 3. I've got myself a point. I said the x-intercept is when y equals 0. Hopefully that makes sense, that if it's going to cut the x-axis, y is not going to be positive or negative, y is going to be 0. So I'm just going to let y equals 0 and rewrite this equation, but instead of y, I write 0. 0 equals 3 minus half x. You can move either the 3 or the minus half x. I'd rather move the minus half x and add a half x to both sides, because then it gives me a positive half x equals 3. Divide both sides by a half to get rid of it. 3 divided by half is 6. There is my x-intercept. And it's always nice, I reckon, to do it roughly to scale. That looks 3-ish, that looks 6-ish by comparison. And again, oh, David. That is a perfectly straight line, okay? Another check before I move on. The gradient should be a minus a half. Is it? It's minus. Tick. Does it look like a half? 3 on 6, vertical and horizontal. Yeah, a half. Perfect. Well done. Okay, I need to get used to how to use this. A5, find AB in the equation following graph. We know what AB is. A is the y-intercept. Right there. Technically a q-intercept on this, but it's still okay to call a y-intercept. B is a gradient. I'm going to do what I said before. I can see it's negative. Let's confirm that. Now let's look for some points it's easy to read. It's not easy to read that point here, or that point, but that's easy to read. It goes right through there. So let's consider this triangle. It's gone minus 100 over a run of 20. What does that simplify down to? Minus 5. So what's the equation? Well, instead of y equals a plus bx, the y is a q axis, the a is a 500, the b is a minus 5, and the x-axis is a t. Okay, here comes an awesome part of the video where I put stuff into the calculator without having it on camera. Okay, now I'm not going to go through the calculator in detail because it's up to us to know our own type of calculator. I'm using the FX82AU, so I'll just babble while I do this. I'm going to mode stat and choosing the a plus bx option. It'll be the lin option. Oh no, or reg on the sharp. I think it's lin then reg. Anyway, that's for you. 241 I'm putting in and a 341. Note that we'll always put them in. X's is the first row, Y is the second row. We're never going to flip it. It's just, that's the way we'll go with these things. So instantly I can know that the x-axis is going to be renamed as C and the y as P. That's how we're going to input it. We're all good. 241, 341, 268, 382, 307. Go back to the top for the y's. 49, 593, 201, 760, 352. I'm done, all clear on this. Shift 1, I'm going to regression option. That's probably what I was thinking of before. And it wants the correlation coefficient, the little r, so I've picked that and I pressed equals and it says 0.996. It was followed by 1, so I didn't round up. There's the correlation coefficient. The one set A, I go back into, on my calc, shift 1, regression, and the A equals is minus 1178.4, correct 1 dp. Go back in that spot, and my B option tells me 5.09, so on. So the 0 rounds up, because it's followed by 9, 0 rounds up to 1. 5.1, and then it wants the equation of the line. Well, as soon as it says equation of the line of best fit, I think equation is y equals, flashbacks, it's y equals a plus bx. But we said the y-axis, what was it? Y is a p and x is a c. Y is a p, X is a C, A is a minus 1178.4, and B is a... So the profit equals minus 1178.4 plus 5.1 C. That's my equation. A6, logs. Remember with logs, think we're not asking about multiplication, we're asking about powers. Logs are basically opposite to powers. So this is not saying 2 times what gives 32, because 16 would be a popular answer. No, it's saying 2 to the what gives 32. So then I could use the calc or just go through it myself. I know 2 cubed is 8, 2 to the 4 would be 16, 2 to the 5 would be 32. There we are. Same method, y to the 3 equals 8. What's the opposite of cube? I know if I had an x squared equals something, the opposite of squared is square root. So what's the opposite of cubed? Cubed root. So to get rid of a cube root. And what's the cube root of 8? It'd be a 2, because 2 by 2 by 2 gives 8. Fully simplify. Now, I've got log A's. Now, I'll look at a different option, but at the moment, firstly, I'm looking at that thinking, I can just use the first log law. The first log law said, basically, log of A plus log of B is log of AB. You can combine these pluses, but you times the numbers. So as long as they're the same bases, they're all log A, so that's all good. 1 times 2 times 3, 1 times 2 is 2, by 3 is 6. Can I do anything further with that? That's asking me A to the what gives 6. I can't answer that. I can't simplify that any further. I don't know what A is, so I can't answer you. All I can do is simplify it, and I've done it. Note that if you thought, hang on, can't we do them individually? Well, I can't do log A to the what gives 2, I don't know, A to the what gives 3. Technically, A to the what gives 1, I can answer that, just in case it's a question. Because log A1 equals I don't know means A to the power of I don't know equals 1. That's one I can answer actually. Anything to the naught is 1. So this is extra nerd info. What is log A1? It's actually naught, because A to the naught gives 1. But does that make sense? Hopefully, because what would be the answer to log A2 plus log A3? It'd still be log A6, wouldn't it? Who cared about the times 1? So just you know, it didn't make a big difference, but hopefully it was fascinating. Log x25 minus log x5. Well, we said if we plus these logs, they come together as times. If we minus them, they come together as divide, as long as they're the same base, and they are. 25 divided by 5 is a 5. Can I answer that? X to the what gives 5? No, I can't. I'm finished. Next one looks similar, but no one ever mentioned numbers out the front with my log laws. If you were an algebra person, you could factorise those twos out. I'm not going to go that way, but that would be fine. What I'm going to do here, though, is say we had a rule for getting rid of numbers out the front you didn't want. It's basically the third log law said if I had a power here, it could come to the front. Well, that same law can go backwards. If I've got a number at the front, it can become a power. That can be a log 3/6 squared. The 2 from the front that was multiplying became squared, minus log 3/2 squared. What is 6 squared? Oh no, that's a 36. Minus log 3, and 2 squareds are 4. So that's a log 3. Let's use the same base, so 36. It's a minus question, so I better divide. 36 divided by 4 is 9. Log 3, 9. 3 to the what gives 9? 3, not times 3. 3 to the what gives 9? 3 to what number gives 9? It's a 2. Okay, 3 is tempting, but 3 squared gives 9. No, my answer is 2. All right, B1, onto the larger content of the paper, the B questions. Now we start with exponential equations, and we've got, well, y equals 3 to the x. So this, first thing to note, just in general, I'll just make something up. Y equals 3 times 4 to the x. Whatever the first number is the y-intercept, I assure you. Because here, the 4 to the x, if I said, well, what the y-intercept is when x equals 0. 4 to the 0's a 1. 3 times 1 is 3. 4 to the x effectively disappears. So the y-intercept is always that front number. So what's the 4 tell me? I don't really care that it's a 4 or a 5 or a 6. I just care whether it's above 1 or less than 1. Because if I'm getting 3 and timesing it by 4s, it's obviously getting bigger. This number tells me if it's greater than 1, I'm going to see it as a growth equation. But if I'm timesing by something less than 1, it's a decay. Okay, look at the first question though. There's no number out the front, but is there? It's like there's a 1 times there. Yeah, it's 1 times 3 to the x. The same with this part IV down here. There's a 1 times out the front. If there's nothing written there, it's a 1 times. We just didn't bother writing it. So part I and IV should both have y-intercepts of 1. So it's a race between C and D. Part I has a 3 to the x. Obviously that's growth. It's getting times by 3. Which one? Y-intercept of 1 with growth, that's C. The other one is 0.3. Yeah, 0.3 is less than 1. It's got a y-intercept of 1, but it's decay. That's D. The other two, y-intercept of 3, y-intercept of 3. We're on board. It's good. AB, one of them's decay. This one's decay. 5, that's going up. So the y-intercept of 3 with decay is B. The y-intercept 3 with growth is A. Kabad. On a tiny island in the Pacific, potentially should have capitalised that. The population of rabbits is growing out of control. The number of rabbits grows exponentially according to the following function. A few words, exponentially is just this whole topic, you know. Exponentially just means we've got this power up here, okay? It's an exponential. So all of these exponential ones are all actually very similar questions. Where T is time in months, noted. So what that equation says is the population of rabbits is 12 times 1.2 to the, and just put the number of months in here and it'll tell you the population. How many rabbits are there initially? Well, if you can think of it as what I said before, the number at the front, I've done it again, is always the y-intercept, as in y-intercept. This is growth. I don't really care about the stuff to the left because I don't care about negative time. The y-intercept is the initial amount. So whereas the 12 is the y-intercept, you can also call it the initial value. And that's confirmed because initial means time equals 0. If I said 1.2 to the 0, we said anything to the 0 is 1, it's just 12 times 1. Yep, how many rabbits are there initially? There are 12 rabbits. And I knew that by, let's just say I subbed in T equals 0. How many rabbits will there be after 1 year? None of us are going to put in T equals 1 because we all read that the T is in months. So 1 year is 12 months. If the T's got to go in months, so be it. P equals 12 by 1.2 to the 12. 12 times 1.2 to the 12 is 106.99, blah, blah, blah. It didn't tell me what to round to, but I think no decimal places is nice. To the nearest whole rabbit. 106.9, that's 107. Rabbits to the nearest whole rabbit, or just good on naught decimal places, quicker to write. After how many months will the population double itself? Well, we know it was 12. So we're saying find the time till you get to 24. So let's get this initial equation. Instead of writing P equals, let's replace the P with 24. This time the unknown is the time. We've got to find that T. It might be tempting to think I can do 12 times 1.2 to the T, but that would be doing times before power, which is against the rules of BODMAS. What we can do, though, is divide both sides by that 12. So 24 and 12 is a 2, and the 12 disappeared from there. And that's the point where we say, this is where I want to bring that T down, so I better use logs. So I'm just going to make a space here. And the way to do that is, well, if left equals right, log of left will equal log of right. How did that help me? I can now use that log law. This T disappears and can be a multiplier out here. It's multiplying a log of 1.2. Log of 1.2 is just a number. So I'm going to divide both sides by log of 1.2. It's gone, and here is my log of 1.2. So I've got T equals log 2 on log 1.2, which is pure calculator stuff. Log 2 divided, log 2 divided by log, bracket, David. Log 2 equals divided by log 1.2 equals, wow. To 1 dp, that's 3.8. Don't leave it like that. Times in months, you've always got to give it units. 3.8 is useless, but 3.8 months is a winner. Oh, to be technical, we wouldn't take off marks there because it does say after how many months. So if you wrote 3.8, it's already said months. But if it just said after how long, then you'd have to write months. Let's just go with it. Let's write the months there. It's a good habit. A 55-gram sample of a radioactive substance is found to decay at a rate of 2% per day. This is still like, what was that first example I put up there for the graphs? I said y equals 3 times 4 to the x. Let's look at that for a second again. Y equals 3 times 4 to the x. All of these are in the same format. This time I want to construct an exponential equation. It's like this. Describe the mass. So instead of y equals, I'll call it m equals. Initial value we said was out the front. Well, that's 55 grams. Don't bother putting the grams into a formula ever. We know the formula is created using grams, but don't write grams there. It just gets really messy. Times, this one kept getting times by 4, this example I've got here. Well, this one isn't getting times by 4. This has got a slight decay at a rate of 2% per day. Now remember, timesing something by 100% doesn't do anything. It's exactly the same as times by 1, doesn't do anything. So I don't want to times by 100%, I want to reduce it a bit. I want to times it by 100% minus 2%. 98%, that's a reduction of 2% per day. My 100, which does nothing, but take off 2, so it's 98%, which I know is 0.98. Any percent divided by 100 gets me back to a decimal. To the power of, well, not x in this case, in this size, it's t. T's our other variable. Instead of y and x, it's m and t. That's the equation. So they all look very similar. Initial amount at the front, some multiplying factor, which in this case is showing decay, it's less than 1. To the time. How much of the sample remain in 31 days? Well, time is in days. So in other words, it's just saying when t equals 31, what's the mass? Well, it's 55 by 0.98 to the 31. 55 by 0.98 to the 31 is 29.40, but it says correct to one decimal place. The units are important. Again, I know mass was in grams, so there it is. Now, here you could argue. I've got a habit, when I round something, I always write in brackets what I did. Technically, again here, because the question said write it correct to one decimal place, I don't have to write this 1 dp because I just did what you asked me. But again, it's a hard habit to break, and I don't want to break it, because if it just said how much of the sample remained and didn't tell me how to round it, I would have to write what I did, okay? It's just a good habit to stay in anyway. I'm going to keep doing it. Can't stop me. Find the half-life of this substance. It's like the previous question was how long till it doubled? The rabbits went from 12 to 24. Well, that's okay for a growth one, but for a decay, it's got to be how long till it halves. Well, I know my equation was m equals 55 by 0.98 to the t. And if I just go to the calc, well, what is half of 55? It tells me it's 27.5. So I want to know the time is the unknown for when the mass is 27.5. Let's treat it the way as we did the previous page. First, let's divide both sides by 55, and 27.5 on 55 is a half. No big surprise. We got a 2 when we're asking how long till it doubled, and we get a half when we're asking how long till it halves. It's a log question again. I'm going to write, because I want to get this t down, so I'm going to write log of the left equals log of the right. I've got that power of t there. I know that I can bring that down to the front. And I know I can divide both sides by that log of 0.98. So that comes over here is a log of 0.98. And I go to the calc. A log of a half divided by a log of 0.98 equals 34.3 units for time were days. And there's my habit, 1 dp. Okay, the next question, look, it's the same. It's the same as all the others. You can use, there's a formula provided if you want. For this, we can use the formula A equals P outside of 1 plus R all to the n. But look at what it is. It's some final amount is equal to some initial amount, the principal, times some growth, which is 1 plus a bit, to the number of days, weeks, whatever we're doing. So I'm going to do it manually. I'm not going to use a formula, but do as you feel. First, I notice compounded monthly. It's even bolder to tell us whatever it's compounded by, whatever those time periods are, we've got to convert everything to it. So this 9% per annum, sure, I might get 9% a year, but I'll get 9 divided by 12 per month. And 9 on 12, call it 3/4 or call it 0.75. I'm only getting 0.75% per month. Okay, so it's a very small interest rate. $800, well, $800 is $800. You don't convert it to per month. There's no month involved. But 5 years, yeah, that's gone. Instead of 5 years, 5 times 12 months, that's 60 months. So I've converted. I'm right to go. So whether you're using this formula or not, I'm going to say my final amount is the initial amount, which was Ruprecht invested $800. Again, I'm not going to write the dollars there. I don't like units in the question. Times a multiplying factor. Now, these numbers aren't pretty, but it's exactly the same as what we did before. When I decreased by 2%, I took 2% off 100. Here I'm increasing by 0.75%. So what's my multiplying factor? It's 100 plus the 0.75%. 100.75%. 100 plus 0.75. It's an odd looking one because it's a tiny percent increase, but that is what it is. And remember, I always put it in as a decimal. A decimal was divided by 100. So I've got to put a 1.0075. That's my multiplying factor. Very small increase. To what power? 60. I'm doing it 60 times, 60 months. So 800 times 1.0075 to the 60 equals 1252.54. It's followed by a 4. It says the nearest cent. That's the cent column. So I leave it, only followed by 4, don't round up. Give it some units as dollars. And no, a lot of people are tempted to round that to the nearest 5 because that's, in a shop you get change of 5-cent increments. No, to keep this exact. This isn't like, we're not taking it out over the counter. It's on our balance as $1,252.54. And I did that to 2 DP. Exponential's gone. On to stats. Water. Following pie chart shows the raw data. Okay, so this is just number of students. There's 540 in total, 60 and 135, 180 and 165 add up to 540, okay. How many degrees of the circle does math occupy? It's obviously, the diagram doesn't have to be to scale, but it looks about right. And it's a fair chunk of it, a bit over a quarter, a bit over 90, I reckon. But let's do it accurately. How many degrees? Well, what fraction of the circle is maths? There's 165 students over a total of 540. That's what fraction of the circle is maths. And we want to know what fraction of the degrees. Well, the degrees is 360 in a full circle. So what is 165 divided by 540 times by 360? 110 degrees. My estimate was, something a bit over 90. I'm happy with that. If 14 people change their mind from humanities to maths, as they should, what would be the new maths percentage? Okay, not that we calculated the old maths percentage, but didn't ask for it. 14 people change their mind. Humanities, sorry about that. You're down to 166. 14 changed, and those 14 added to here to give me 179. So my denominator is still 540 people, but what's the maths percentage? Well, there's 179 people heard maths over the same 540. That's a fraction. A fraction times 100 turns into percent, which it asked for. 179 divided by 540 times 100, and I've got 33.1% as directed to 1DP. If another 24 people were surveyed, we've got to catch on to that and go, not 24 people change their mind. We've got new people in the survey. I'm just going to note that here. Instead of 540 people, we've now got 564 people, 24 newbies. 12 of them said they preferred art. What was art's number? Art was 60. Now 12 more makes it 72. So the art number now is 72 out of the new total of 564. Still times by 100 to convert that fraction to percent. And 72 divided by 564 times 100 gives me 12.8%. Okay, I'm just going to check that I've done that right because it was 540. Ooh, what's that? No, don't move. Okay, stop it. 12.8%. All right, fantastic. The following table shows a selection of results from a test out of 5 marks. I like to get the head around the results to make sure that I'm doing it right, that I'm aware of what the table means. Like, the test is out of 5 marks. So a test result or a score of 0 happened 4 times, 1 happened 6 times, 2 happened 3 times, 3 happened 3 times, 4 3 times, and 1 person got 5 out of 5. A good thing from that is I see a lot of students look at this and say, okay, so how many people sat this test? 1, 2, 3, 4, there's 6. There's only 6 scores. There's a 0, a 1, a 2, a 3, a 4, and a 5. It's not true. There's not just 6 people. 4 of them are 6, that's 10. 3, that's 9, 1. There are 20 people here. So we'll check in a sec. If we're going to get asked for the mean of these numbers, don't just add these up and divide by 6. Or if someone was going to ask us for the median, don't just go in the middle of here and say it's 2.5, because we'd have to write them all out. There's 20 numbers, not just 6. Anyway, let's finish doing the thing. If frequency is an F column, CF is when we basically zigzag. We say, okay, there's 4 scores initially. We'll start at 4. Plus 6 more is 10, plus 3 more is 13, 3 more is 16, 3 more is 19, and 1 more is 20. There's a check. The total of the frequency column will always equal the last number in the CF column. So we're good there. Note the CF column we're going to use to help find median. That's what it's for. Or to draw a CF polygon or histogram, otherwise known as CF polygon as OGI, but not now. The FX column literally means F times X. And all that's doing is adding up all those scores so we can find the mean later. So I've got 4 lots of 0, which is 4 lots is 0. 6 lots of 1, which is 6. 3 lots of 2 is 6. 3 lots of 3 is 9. 3 4s is 12, and 1 5 is 5. So the sum of all these scores, because there's really 20 scores all up, is what we've got. 12 and 12 is 24, plus a 5 is 29, plus 9 is 38. So let's answer our questions. Use the table to calculate the range of the data. Again, just think what we're talking about. The data is test scores, not the range of the frequency or anything else. What did the test scores range from? The highest test score was a 5 and the lowest was a 0. So highest minus lowest, 5 minus 0. There was a range of 5 in the data. The mode, and give a reason. Well, the mode is the most occurring, as in the highest frequency. The highest frequency was 6, which doesn't mean the mode is 6. It means what score happened 6 times? 1 did. So the mode is 1. The reason doesn't have to be an essay. The reason is occurred most times. And I'll be so kind to even say 6 times. Yep, that'll do. The median, give a reason for your answer. Again, I know we'll get answers of 2.5 because it seems to be right in the middle. Okay, that's getting annoying now. Okay, but truth is, I'd have to line up 20 numbers. Now, I understand why you'll think, well, the halfway mark is the 10th score. But really think about lining up 20 numbers. I would line up 10 numbers here, and I'd line up 10 numbers here. And my halfway would actually be halfway between the 10th score and the 11th score. Like when I hold up 2 hands and say, if I've got 10 scores, the middle is my 2 thumbs, 5th and 6th. So it's actually the 10th score and the 11th score I want. So, and give a reason for your answer. It's like show you're working. This is good enough. Showing 10th and 11th. The 10th score I can see, like the first 4 scores are all noughts, but then the 5th through to the 10th score are all 1s, so the 10th score is a 1. The 11th score, well, the 11th, 12th, 13th scores were all 2s. So the 10th score was 1, the 11th score was 2. The median, I shouldn't ever try to do curly brackets, is halfway between them, or the average of them if you like. The median's 1.5. Call it 1.5 if you want, doesn't matter, fraction decimal same. And the mean, again, remember, the mean is the sum of all scores divided by how many scores. I know there's 20 scores, and I know the sum of them is what the FX column did for me, 38. What's 38 on 20? Well, that's 1.9. I also like to check that makes sense. Do I agree the mean test result might have been about 1.9? Yeah, from 0 to 5. Like if the answer was 6.9, that's impossible. your mean's got to be between the lowest and highest. And yeah, that sounds about right. There are a lot of low scores. All right, moving right along. I didn't. Okay, I should be scrolling. Actually, that's safer. Don't touch it. For the following data, 4, 3, 2, 10, 1, no one's forcing us, but I like to write in order. 1, 2, 3, 4, and a 10. What's the range of the data? Well, 10 minus 1, highest minus lowest, that's 9. What's the mean of the data? In this case, there are only 5 scores. So the mean is the sum of them. 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 10 is 20, divided by 5 numbers. The mean is 4, that's right. Complete the following table. It's got the scores already listed, 1, 2, 3, 4, 10. And it says x minus x bar, which means, well, what is x bar? 4. This may as well say, get your mean and take 4 off it. Get your score and take 4 off it. 1 minus 4 is minus 3. 2 minus 4 is minus 2. 3 minus 4 is minus 1. 4 minus 4 is 0. And 10 minus 4 is 6. You'll notice that this column always adds up to 0. And again, it does. So it's not very useful to calculate averages on. That's why the next column is the same number, but squared. And don't bother putting bracket minus 3, bracket squared in the calc. I promise you, any negative times another negative becomes a positive. So ignore the negative. It's going plus. 3 squared is 9, 2 squared is 4, 1 squared is 1, 0 squared is 0, and 6 squared is 36. But in the total box, well, a 36 and a 4 is 40, a 1 and 9 is 10. I reckon it's adding up to 50. Next question says, what is the standard deviation of the data? Due to that wording, I could answer this on the calculator, and that would suffice. But normally, my wording would be, use the above table to find the standard deviation of the data, forcing us to have to understand how that table helps us. And I'm going to use the horrible looking formula, but quite useful, that the standard deviation, why am I writing it backwards? Standard deviation is equal to the square root of the sum of x minus x bar squared over n. It looks horrid, but have it on your resource sheet, because all that's doing is reminding me that, okay, it's the square root of something on something. This whole sum of the x minus x bar squared column, it doesn't mean you've got to get a number and square it, or you've done all the work. Here's the x minus x bar squared column, and here's the sum of it. It's just a 50. This thing here is 50. Number of scores is 5, because there's only 5 scores. That's my answer. Square root of 50 on 5. In other words, square root of 10. In other words, root 10 is 3.2-ish. 3.16, 3.2 to 1 dp. Done. Okay, up to B3, a second bit of stats. So we've got a cumulative frequency histogram, that's the boxes, and the ogive, that's our line, already done for us. Results an exam for a large class of students. So it looks like a fair spread of results from 0 all the way up to 100. Now it says to find a good estimate for the median of the data. It doesn't ask us to find a poor estimate. You word things weird. But it's definitely an estimate because, let's look. There were 5 results between 0 and 10. What were they? I don't know. Maybe they were all 2s. I just don't know. So it's going to be an estimate. We don't have all the data. But that's the nature of the beast. We're going to find an estimate for the median. Now, don't think that they've got 70 bits of data because the graph doesn't actually go up that high. The graph goes to 60. Okay, so it's not 70 bits of data, it's 60 bits of data. So the median is the halfway mark, which is 30. Now, before we talked about it and said, hang on, the median of 20 scores was the 10th and 11th. Isn't it the same? Well, yeah, it is. You can say that the middle score really is halfway between the 30th and the 31st score. So if you want to go to 30 and a half, be my guest. But it's an estimate, and good luck being that accurate. So it's good enough to just say, look, half is 30. I don't have a ruler. The 30 goes across until it hits the ogive. And then that number comes down and, well, some might call that 72 and a half, some might call it 72, some might get 73, I'm a bit off. They're all good answers. I'm going to go with 72 on the line I drew, but that's my estimate of the median. Now the next bit, what is the least mark a student would have to get to be in the top 25% of the class? Hopefully you can see this is talking about quartiles, because quartiles is when I split it into 4 equal bits. And there were 60 bits of data, 60 students. 60 divided by 4 is 15. So if I line up all the students from the lowest mark to the highest mark, well, probably get in lots of trouble. But here's the bottom 15, and then the second quarter, the third quarter, and the fourth quarter. It's asking us, for this top 25% of the class, what was the least mark? I need to know the mark that I get here. It's asking me for the Q3. That's all the Q3 is. The Q1 is the top mark in the first quarter, top mark in the second quarter is Q2, top mark in the third quarter is Q3. So we're saying Q3 is the mark that differentiates the top quarter of the results. So let's find Q3, back up the top. Q3 would have 15 for Q1, 30 for Q2, 45 for Q3. So just take the 45 over until it hits, again, not the box, till it hits the ogive. That does it nicely. That's 80. That's easy to read. A mark of 80 separates the top 25%. What's the least mark? Well, I've done too much scribble. 80. For this data, we're back to the calc. Riveting. First I'm going to do mode comp, which is me jumping out of stat mode to clear the data. Now mode back into stat mode and one var on this calc. Put an 11 and a 12 and a 15 and a 16 and an 18 and a 22 and a 29 and a 30 and a 39 and a 45 and a 51 and a 53. Why so many numbers? Yeah, okay, cool. I've done it, all clear. Use a calc to find the sample standard deviation. Now my calc, let me confirm, variance, my calc has these two options. It has a sigma x and an SX. This is sample. This was population when you have all the data. This one's just asking for the sample standard deviation. As long as you know which one's which on your calc, we're all good. Other calcs will have like a sigma n-1, or it could say x n-1, anything like this. If there's an n-1 or an s there, that's the sample one. For me, the answer is 15.26. All right. Next question, what's Q1 and Q3? Well, we've already discussed that. It's splitting the data up into 4 equal groups. How many bits have we got? 1, 2, 3, 4, 12. 12 bits of data divided into 4 groups. That's 3 per group. So here's my partitions. This will be my Q1 and my Q3 and my Q2, not that it's asking for it, but Q1 will be, well, the average of 15 and 16, which is 15.5. And Q3 will be the average of 39 and 45, which would be 42. Okay, what's the interquartile range? Well, that's just defined as Q3 minus Q1, which is 42 minus 15.5, which is, I just don't want to, 26.5. Give the 5-number summary for this data. 5-number summary is the Q1, Q2, Q3 bounded by a min and a max. So it's 11 and 53 on the ends. Q1's a 15.5. Q3 is a 42. What's Q2? Q2 is the average between 22 and 29. So if I add them, I'll get 51, which would be 25.5. 25.5. Okay, and the box plot is just plotting those 5 numbers. That's where it comes from. The 11, how big are these gaps? There's 5 gaps for 10. 10 divided by 5, that's 2. 2, 4, 6, 8, 10. So 11 would be 1 bit past. 15.5, well, 15's in the middle. It's a bit closer this way. Don't need to be so, it's hard to be accurate here. 25.5, well, 25's the middle, so 25.5's over a bit. 42 will be right on the line, and 53 will be in between lines. Remember, I don't have a ruler, so I'm just going to curve it up. Box plot, sorted. Okay, a bit of normal distribution. Talking about a breakfast cereal company determined their mean weight of their cereal box was 646 grams. Let's put that here. Here's the mean, 646 grams. And a standard deviation of 4 grams. That means I'm going up and down by 4s. 646 plus 4 is 650. Plus 4 is 654. Plus 4 is 658. Down 4s will be a 642 and a 638 and a 634. Now, there's also percentages associated with this normal curve. Like there's a 34% here and a 13.5% here. I'll stop writing percent. I'm going to run out of room. If you're wondering where these numbers come from, lectures are awesome. 34, 13.5, 2.35, 0.15. So what percentage of boxes would you expect to contain between 646 and 650? 646 is here and 650 is here. Straight off, it's 34%, too easy. If it was 646 to 654, I would have to add 2 bits. Or whatever it is, just add up whatever section it's talking about. The next one says the boxes are advertised as containing 638 grams. Well, that's this mark. And we're asking how many boxes are going to contain less than that. So it's how many boxes, not just what percent. Firstly, what percent is it? It's 235 and a 0.15. Add them together. 2.5% are going to be underweight. People are getting ripped off. 2.5% of the boxes produced are underweight. Okay. How many boxes? Well, there's 5,000 boxes of cereal per day and 2.5% of them underweight. I'll just do it manually. 2.5% means 2.5 on 100 times 5,000. I can lose a couple of zeros. 2.5 50s. Well, 2 50s 100. Half of 50 is 25. That's 125 boxes per day. The marks from a test are normally distributed. There's that again with a mean of 62 and a standard deviation of 6. And we're given a z-score. Now, there's 2 ways. You can just use the formula here if you want, or you can do it by just the understanding of what a z-score is. And I want to do it both ways. By understanding of a z-score, is me drawing this and putting the mean in the middle, which is a z-score of 0. A z-score of -1, I'm going down the minus direction, would be 62 minus 6, would be 56. That's a z-score of -1. Take off another 6, I'd be down to 50. That's a z-score of -2. Take off another 6, I'm down to 44. That would be a z-score of -3. Where would a z-score of -2.5 be? Slap bang in the middle, 47, between 44 and 50. Or I could have said, no, I'm just going to use the formula and do some algebra. And if I did that, replace the z-score with what we were told it was, the actual mark is the x, the mean is 62, and the standard deviation is 6. I can't get at that -62 because it's trapped in the top of a fraction, but I can multiply both sides by 6 to get rid of a divide by 6. -2.5 times 6 would be -15 equals x minus 62. Now I can add 62 to both sides. -15 plus 62 is 47. Same for the next question. Either use the understanding of z-scores or just go for the formula. Most would probably say the formula is quicker, but is it as fun? Here's my curve. My mean is 75. My first question is referring to 67, so I'm going to go down. Z-score of 0 is in the middle. Standard deviation of 4, okay. Remove 4 from 75. A z-score of -1 is a 71. Remove another 4, I'm down to 67, which is a z-score of -2, and I just answered my question. And the second one is even easier. What was the z-score of, if the mean is 75, a score of 75 was a z-score of 0 from the mean. But I could have done the formula. I could have said z equals x minus x bar on SD. For the first one, that would have been a score of 67 minus a mean of 75 on a standard deviation of 4, which is -8 on 4, which is -2. Or for the next one, it would have been z equals a score of 75 minus a mean of 75 on who cares, because it's 0 on 4 and 0 on anything is 0. Second last, we're into probability. What's a probability? You get a multiple of 3 on the uppermost face of the die on the first roll. Very wordy. In other words, what's the chance of rolling a die, not 50 times yet, just on the first go, in getting a multiple of 3? My options that I can get on a die are 1, 2, 3, 4, 5, 6. And multiples of 3 is basically 3 times a whole number. Even 3 itself is considered a multiple of itself. 1 times 3 is an answer, 2 times 3 is an answer. So the only options we've got here are 3 and 6. 2 out of our 6 options are multiples of 3. Nothing wrong with an unsimplified answer unless it was requested, but 2, 6, 1/3, either way. Now, if I do that 50 times, my expectation would be the number of times I do something times the probability of the event I'm talking about. Here I'm doing it 50 times a third. It's 16.6 repeater. Don't leave it like that. Can you roll a multiple of 3? Can you roll a die 0.6 repeater times? No, it's got to be a whole number. And the nearest whole number is 17. Cards, I'm requested to select a card at random from a standard deck of cards. I know there's 52 cards in a deck. What's the probability I select a black 4? Well, hopefully you either know cards or you've just got a cheat sheet on your cheat sheet, and it'll tell you there's only 2 black 4s. There's a 4 of clubs and a 4 of spades. So that answer would be fine, so would the simplified version. With the next one, I've got to slow down and be careful, because the trap here would be saying, there are 4 6s in a pack, and half the pack is black. Hence, there are 30 options to get this or this. It's not an and. If it was an and, it would be like the previous question would be, how many black 6s are in the pack? There's 2. No, it says or. I don't care which one I get. But what we've got to think of is, I'll get rid of that 4 and say, no. And say, there are 26 black cards. Okay? How many more 6s are there? I've already got 2 6s counted already in the black cards. How many more 6s are there? There's only 2 more. Because there's 2 red 6s. So there's only 28 cards that satisfy this or. 26 black cards and 2 more 6s, 28 cards in total. So that's a good answer. 14 on 26 would be fine. 7 on 13 would also be fine. C, a survey is conducted on the transport choices for 60 people on a small island. Okay, 26 for cyclists, 36 motorists. Okay, so we've got cyclists 26, motorists 36. We've got potential overlap here because someone could be both. And 9 were neither. There's no overlap there. You're either a cyclist or a motorcyclist or both or neither. So let's just start our Venn diagram. Clearly our 2 categories are cyclists and motorcyclists with some potential overlap. The neither is in here. So there's a couple of ways to do this. What I'm going to say is, look, there's 60 total in the Venn diagram. I know there's 9 out here. So there's only 51 spaces left to go into these circles. And how many are we trying to fit? 26 and 36. I'm going to add them. 6, 6 is 12, 3, 4, 5, 6. My cyclists and motorists add up to 62, but I've only got space for 51. Some of them must have put their hand up twice. And how many is it? It's whatever the difference is. If I can only fit 51, I'm trying to fit 62. The difference is 11. 11 people must have put their hand up twice. That's why it seems like I've got 11 too many people. I don't really. So if there's 11 in the overlap and there's meant to be 26 cyclists, what's 26 minus 11? 15. Now the cyclist circle has 26 in it. That's what it should be. The motorist circle should have 36 in it. Well, it's already got 11, so 36 minus 11 is 25. Now it's got 36. Let's check that everything adds up to 60. A 15, 11 is 26, and a 25 is 51, and a 9 is 60. All good. If a person were chosen at random from the above survey, determine the probability that the person is a cyclist or motorist only. How many people in the survey? 60. It didn't ask for how many people. It says determine the probability, so make sure you're giving a probability. How many people are a cyclist or motorcyclist only? If they say only, it means it's just only a cyclist or only a motorist, not both. It's the 15 plus 25, which is 40. My answer is 40 on 60. Call it 4, 6 or 2/3 if you want. All good. Determine the probability that the person is also a motorist given that they are a cyclist. Ooh. We're given a condition here. This is conditional probability. Given that they were a cyclist, saying, okay, I'm telling you that I talked to a cyclist. How many cyclists were there? Well, the question said there were 26 cyclists. The C circle adds up to 26. There were 26 cyclists. So given that the person I was talking to was a cyclist, what's the probability of them also being a motorist? Well, how many of those 26 people in the C circle are motorists? 11 of them. 11 on 26. Done. All right, apples. We've got some red, green, rotten apple, not rotten. Why did I write apple? Why did I just write rotten and not rotten? I didn't have to write apple again. Okay, there's room for some column totals. Let's do it. We're probably going to need them in a sec. 5 and 20 is 25. 10 and 30 is 40. 5 and 10 is 15. 20 and 30 is 50. My row adds to 65. My column adds to 65. Everyone's happy. If an apple is chosen at random, what is the probability that the apple is green and not rotten? Not rotten and green. And it says probability. So 30 of them are green and not rotten out of 65. Simplify it if you want, but it'll do. If an apple is chosen at random, what is the probability the apple is red? Okay, so it's still out of the whole lot of apples. How many red apples we got? There's only 25 red apples, 25 on 65. If I choose a green apple, oh, there's a condition. We're only choosing from the green apples, of which there are 40 green apples. So my denominator is, so out of choosing a green apple, what's the probability of choosing a rotten one? Well, how many of those 40 were rotten? 10. 10 out of 40. A bag contains 5 red marbles and 7 blue marbles. Water. Here we go. 5 red, 7 blue. 2 marbles are selected from the bag. The first one is not replaced while the second marble is selected. So let's do the first choice. The first selection is, it's either red or blue, and it's a weighted tree diagram with some probabilities on the arms. Chance of getting a red out of this bag is 5 out of the total 12 marbles. Chance of getting a blue out of the bag is 7 out of the total 12 marbles. And the arms should add up to 1. And 5 twelfths and 7 twelfths do add up to 12 twelfths, which is 1. Now, this next bit here is assuming that I did pull a red marble out the bag. So my bag now looks like this. Instead of 5 reds and 7 blues, there's only 4 reds and 7 blues now. So given that I pulled a red out already, my chance of getting another red is now only 4 out of the remaining 11. But my chance of getting a blue is 7 out of the remaining 11. They still add up to 1. Or if I'd come down this pathway and I'd picked a blue instead, then my bag looks like this. Instead of 5 reds and 7 blues, it's still 5 reds, but it's only 6 blues. So I've got 5 out of 11 chance of getting another red and 6 out of 11 chance of getting another blue. There's my tree diagram. I'm going to be excessive with it and can't you just rub it all out without me having to scribble everything? Okay. So I could get a red red, a red blue, a blue red, a blue blue. I wouldn't normally do all of this. I'm just doing it in case, you know, the questions, there's more questions than just this one here. What would be the chance of red red in case it was asked? Well, that's the chance of getting a red one and getting another red one. Remember, and is at times. You always times across the arms of tree diagrams. And if you remember back to calculating fractions without a calculator, I would have done a 5 times 4 on the top as 20 and 12 times 11 is 132. To get a red then a blue, it would be 5 times 7 on the top and 12 11s on the bottom. To get blue then red, it would be 7 5s is also 35 on the top, 132 on the bottom. And 7 times 6 is 42 on the top, 132 on the bottom. I want to check that they still add up to 1 because all outcomes that are possible should add up to 1. 35 and 35 is 70, plus 20 is 90, plus 42 is 132 on 132. We're all good. All we need here, probably selecting two blue marbles, is this one, 42 on 132. But just note, the question could say something like, what's the probability of getting maybe at least 1 red marble? If the question was like at least 1 red marble, I'd say you can have 2. You can have red then blue, or you can have blue then red. But you better add up all those 3 options because it's this or this or this. So if someone asked that question, what's the probability of getting at least 1 red marble? I'd say it's this plus this plus this, which is 90 on 132. Anyway, that was not the question. B5, how many different outcomes are possible when 2 dice are rolled, one after the other? Well, how many possibilities were there on the first die? 6. How many on the second die? 6. Is this an or an and? Am I rolling one die or the other? No, I'm rolling them both. It's an and, it's a times. This is like the lecture example of, I've got 4 pairs of trousers and 3 shirts. How many different possible outfits? It's 4 times 3. The number of possibilities is how many ways I can do this times how many ways I can do that. 6 by 6, 36. Next question's the same. How many different outcomes are possible when a coin is tossed 5 times? Toss a coin. There's 2 possibilities. Do it again. 2. Do it again, do it again, do it again. Times them. You might have already thought, isn't that 2 to the 5? Yep, same answer. But that's not there. We're going to have to calculate it. And 2 by 2 by 2 by 2 by 2 is 32. Bowl of fruit contains 3 apples, 2 oranges, 4 bananas. In other words, 3, 4, 5. There's 9 bits of fruit. 1 piece of fruit is chosen at random from the bowl. What's the probability is an orange? Well, there's 2 oranges out of 9. 2 9s. That's a bit kind. I need a 5-digit PIN number. All right, I'm just setting up. Here's my 5 digits. Oh, boxes. Using all of the digits 0, 1, 2, 3, 4. So think to yourself, is this with repetition or without? Can I have the PIN number 44444? No, that doesn't use all the digits. No, it's not repetition. If I repeat any number, I'm not using all the digits. So, okay, this is without repetition. How many different pins can I choose from? Well, how many different first digits could I have? Any of these 5. Since I can't repeat, I've only got 4 left for the second digit, 3 left, 2 left, 1 left. The answer is 5 factorial. It's all of these. I'm doing this and this and this and this and this. 5 4 is 20, by 3 is 60, by 2 is 120. There's our answer. In how many different ways can first, second and third place be filled in a 12-horse race? Well, does the position matter? I think if the position matters, it's a P question. And position does matter. First and second aren't the same. We're not asking, I'm trying to make a team of 3 horses and there's no positions. This is a P question. There are 12 horses and I'm picking 3 of them to come in these places. No, it's 12P3 all the way. Position mattered. 12 picking 3. All right, a hand of cards, 5 cards, is dealt out from a standard deck of cards. How many possible hands consist of only hearts? Well, firstly, does it matter what order I get dealt my cards? Is a hand different depending on what order you got them dealt in? No, not at all. A hand's a hand. You're going to rearrange them anyway. All cards are C questions. Go away P. Now, if I'm getting a hand of 5 cards, they've both got 5 there, that's good. Only hearts, how many hearts in a pack? There's only 13. Ignore the rest of the pack. C's the answer for if only red cards. No, there it is. There's 13 hearts, I'm picking 5 of them. I can do that 13C 5 ways. Now we're still talking about a hand of 5 cards, but we want 4 queens in it. Well, okay. In the same way here, I said I've got 13 hearts, I want to pick 5 of them. Tell me how many ways I can do it. Well, let's split this question into 2 bits. I want 4 queens. How many queens are in the pack? 4. So there's 4. I know card questions are C, and I want all 4 of them. 4C4 is how many ways I can pick 4 queens from 4 queens. And tell you the truth, 4C4 is 1. There's only one way, and that is you've got them all. If the order doesn't matter, if you've got all the queens in your hand, it's a done deal. And I need 1 more card. The debate is, so I'm choosing 4 and choosing 1, so it's adding up, right? But how many cards were left to pick that 1 card from? Well, if all 4 queens are removed, there's 48 cards left. There it is, option B. Option C is moved to probability. So go away, option B. It's got to have a denominator. And the denominator of choosing any set of 5 cards would have to be 52C5. There's 52 cards, choose 5 of them. They've all got the right denominator. Okay, it's all about the numerator. I'm getting rid of D because it's got a P in it. No. All red cards, I discussed that before, that was like up here. All red cards, there's 26 red cards. There it is already. I'm going to choose 5 cards from only the 26 cards and compare that to 5 cards from the entire deck. So the probability of getting this over the total number of options, there it is, done. Oh, no. Now, this one looks fairly familiar, this question from both worksheet and the lecture. Okay, a team of 8 players are to be selected from a squad of 20 for Lawn Bowls tournament. My first question already is, it's just a team. They're not secretary, governor, treasurer. It's just a team. It's a C question. If I had no restrictions, like the first question, all of the squad are willing and able to join the team. In other words, all of the 20 players can be picked from, and I need 8. 20C8 is the answer to the first one. If Agatha, who is one of the squad, must be included, that means I've already put her on the committee or the team, so I only need 7 more people, and I've got 19 people left to choose from. I can't choose her again, so it's a 19C7. If Cornelius and Betty are injured and cannot play, I still need an 8-person team, but there's 2 less people to pick from. Note that question 3 doesn't roll on from question 2. These are standalone questions, so Agatha's back in the mix. But if Cornelius and Betty are out of the mix, there's only 18 people left, but I still need to pick 8 of them. Now, Delilah and Edna hate each other and will not play in the team together. We had one like this in the lecture, and we said, we've got to think this through a bit more because there's a few ways that can happen. If here's Delilah and here's Edna, I can have Delilah in and Edna out of the team, or Delilah can be out and Edna can be in, or we can leave them both out. The only other possibility, which doesn't satisfy our question, is having them both in. That's exactly what we're trying to avoid. So this class might split here on how we do it. Let's do it the first way, where we work out all these 3 options. If Delilah is in the team and Edna's out, I still need 7 more people, but there's 2 people I can't pick from. So 20's gone down to 18. Good recovery. If Delilah's out and Edna's in, it's the exact same setup. It's still 18 to pick from. I'm going to choose 7. If they're both out, again, I've only got 18 people to pick from, but I've got to choose a full complement of 8 because neither of them was on the team. So one of my answers here could be 18C7 plus 18C7 plus 18C8, and that will be correct. For trivia's sake, 18C7 times 2 plus 18C8. The answer numerically is 107406. It's totally fine to leave it in C form unless it's multiple choice. You might just want to compare answers. Like here, I'm going to do a check. I want to prove to you that it's the same method. The other thing I could have done is said, look, all I want to do is exclude the number of ways that they're both in the team. I don't want that to happen. If they were both in the team, that would mean that I only need 6 more people from a team of 8, and I can't pick them again, so I've got 18 people to pick from. So I know that there was a total of 20C8 ways to pick the team, unrestricted, but just subtract from that the things I don't want, which is both them in the team. This will also be right, and I'll just satisfy myself that 20C8 minus 18C6 equals C. There it is. We made it. Okay. I hope that recording worked because the other's stuffed up, and I'm done. All right. All the best, everybody. See ya.